Hey everybody, this is Unit 3, Lesson 5, and we are talking about fitting lines today. So we're going to do a little bit of line of best fit, looking at scatter plots and creating those lines of best fit. Okay, so let's just jump right in it. This is 5.1. You can find this on your Desmos link that is in Canvas. Which line is the best fit for the data in each scatter plot? Okay, so when we talk about line of fit, we're going to talk about if you have a scatter plot and you could draw a line that kind of summarizes all of that data, what would that line look like? And so for here, would we choose the dashed line or the solid line? And for this, guys, we would choose the solid. And explaining my reason, as we can see here, okay, the solid line goes through primarily most of the data, whereas this dashed line, that's not really, it has a different, we can see here that, moving left to right, the dots decrease, that dotted line increases, and so it wouldn't be the best fit line. On number 2, we could choose the dashed line or the solid line. If we were to say what goes through the majority of the data, again, we're talking about the solid line. Now here, both of the lines are increasing, which goes with the scatter plot data. However, we want to see which one of these lines goes through the most of the data, and that would be the dashed line, not the solid line. And then, guys, this one, we can see they really try to take this bottom point and go to the top with the solid. However, what goes through, again, the majority of the data is the dashed line. I'm going to skip these 3 card sorts. You're more than happy to go through these on seeing the greatest slope of those sort of things. Just remember, guys, when we talk about slope, okay, a flat line is 0 slope. A vertical line is an undefined slope. So the higher I increase my line up, and actually, I'm sorry, I'm opposite of you guys. So if your line is looking like this going up, my slope is increasing. Okay, now if I'm going down left to right, okay, so my line is looking like this, okay, that's a negative slope. And so just remember, guys, when we talk about the greatest slope, we're talking about, hey, how vertical is that line moving left to right? And then we go here. So also, guys, here, the greatest vertical intercept. Remember, intercept is where it crosses the y-axis, which is your vertical axis. Okay, guys, write a sentence that describes how y changes as x increases and whether the linear model is a good fit for the data or not. Okay, and so what I'm going to use is I'm going to use an I for increase and a D for decrease, just so you know that I'm going to summarize. Okay, so as x increases, actually, we'll just go ahead and write it. Okay, we can see that y increases, okay, because it's going up left to right. And is this line a very good fit? I would say that it fits very well as we see it goes through the majority of the data. Okay, now here, okay, as x increases, and guys, x just means that it increases as moving left to right. So as x is moving left to right, okay, y decreases because we see that the values of y go down. Is it a line? It's a very well fit line. Okay, you can see that most of the data is on that line. There's not much deviation at all. Okay, on this one, as x increases or as x moves left to right, okay, we can see that y increases. Okay, most of the data fits the line very well, but we do have 2 points that are far from the data, and sometimes we like to use that term outliers, and that I would consider those outliers in that point. Okay, now, guys, when we see this, for D, okay, as x increases, we can see here, guys, I would describe this, it goes down, up, y moves in a wave pattern. Maybe that's a good way to describe it. Okay, and not a good fit at all, I would say, guys, because that line there, that gives you zero prediction on what could happen. All right, here we go. As x increases, y, we see moving down left to right, so y is going to decrease, decreases. Very good fit, except for one point, right? Because we do have that one little point out there. And then we have another one here. Okay, so as x increases, y, let's look left to right, moving up. So y is going to increase. Y increases, and it fits so moderately. I know I just butchered that, moderately. I know I spelled it wrong, but hey, we're going to go with it. Fits moderately well, okay? Just kind of an average fit. And then here, okay, so we say as x increases, let's look, y decreases, then increases, and I would say not a good fit at all, right? Okay, so there is that. So now, guys, what we're going to do is we've seen the data, we've looked at the scatter plots, we've looked at a line of best fit. Okay, now does the data actually show using that, can I create my own scatter plot and my own line of best fit? So right here, okay, fitting lines with technology. Okay, we've got this scatter plot, and we're going to create our own. So what we're going to do here is I do have a Desmos tab open, and what I'm going to do is I'm going to exit my full screens on both of them. Okay, and I'm going to put these up here so that we can see. And guys, I'm going to create a table. Okay, so what we do here is we're going to create a table, and we do have, make sure that this says x1, y1. And we're just going to go down here. So 20 and 6, 18, 4.5, right? 21, 6.5, 17, 3.5, 21.5, 7.5, 19.5, 6.5, 21, 7, 18, oh, and 5. All right, we got to kind of back out so that we can see these. There we go. Okay, that is my scatter plot. Okay, and so now, guys, we want to create our own line of best fit. And so what we're going to do is we're going to click on the box below it, and we're going to enter this formula right here. And so most of you have learned from the city planning that you can't copy and paste in here. You got to create your own. So what you're going to do is you're going to press Y1, and that's going to give you the subscript 1. And then the key to the left of 1, if you hit a shift and hit that, you're going to get that little squiggly line, and you're going to hit MX1 plus B. And what that's going to do is that's going to give you your line of best fit. We're going to get these R's here, which you guys won't know how to do those yet. This correlation coefficient, residuals, and we don't really see those yet. You can plot those, and we'll see there. And you'll learn about those later in the week. And then you see your parameters, which is M and B, which we all know that M is our slope and B is our y-intercept. And so what this line right here, guys, is what that's telling us. Get my head here out of the way. Is that M, I slope, so 0.78 is my slope, and negative 9.4, and we'd round that up to 4, is my y-intercept. And so my line would be y equals 0.78x minus 9.44. Okay? And so that would be y equals 0.782051, if we're going to be technical, x minus 9.4375. Okay? There we go. Okay, what are the values for the slope and the y-intercept for the line? What do these values mean in this situation? Okay, and so we just saw those, and we saw what m is and what b is, and so that we see here, guys, the average temperature outside in degrees Celsius are recorded in the table. Okay, and so doing this, again, X is the amount of pounds sold at the ice cream store, and so we can see here that the higher the temperature is, as the temperature increases, right? So as the temp increases, the amount of ice cream sold increases as well. Okay, and what this means is roughly for every degree Celsius that the temperature raises, 0.78 pounds of ice cream are sold. So for every increase in the temp, there is an additional 0.78 pounds of ice cream sold. Okay. Use best line to predict the y value when x is 10. Is this a good estimate for the data? And so when we look here, guys, we see that I come down here, and at 10, I'm at a negative 1.617. And so is that a good estimate for the data? And it would be no, because you can't sell negative amounts of ice cream. Okay, again, it's a prediction line, and so yes, I mean, not all of the values are going to work, but that is, in that case, no, it wouldn't, because you're not going to sell negative 1.6 gallons of ice cream. Here's some more examples that we will do and practice in class, and you're free to practice as well. But let's jump here to this with Priya using 7 different ride services to get around her city. The table shows the distance in miles she traveled during her last 10 trips and the price of each trip in dollars. Okay, and so let's go ahead, and you know what, we're just gonna erase that and erase this, and let's just create a new table. Okay, and we see that my distance in miles, so 3.1 and 12.5, 4.2 and 14.75, 5, 16, 3.5 and 13.25, 2.5, 12, 1, and 9. Sorry, I got to scroll down here. 0.8 and 8.75, 0.6, 9.75, 4.3 and 12, 3.3 and 14, and I believe that's all of them. Okay, so there's my data, and we look here, and there is my information, and it says determine this, and so to use this, use technology to find the equation of the line of best fit. And so remember, this is going to be y1, and we give our little squiggly line mx1 plus b. And so there is our line. And so we're going to take the m and the b that it gives us here, and we're going to say that it's y equals, we see it rises 1.5, let's round up to 7x, because that's my slope. It's my m. And then I have the b, which is 7.999, so 7.6. Okay. Now we say here, interpret the slope and the y-intercept of the equation for the best fit line of the situation. And so we hear that the b equals 7.6. Okay, so that it costs $7.60 before you even start traveling. So that'd be like the base price. And the M is going to be 1.57. And so that means that the price increases $1.57 for every mile traveled. Okay? So now use this to estimate the cost of a 3.6 mile trip. Will this estimation be close to the actual value? Okay, and so what we're going to do is I'm going to click on my line and I'm going to come up to 3.6 and it's going to be 1325. Okay, 1325. And so what we're going to see is, hey, is this pretty accurate to the data? And we do see that, hey, I traveled 3.5 miles and I paid 1325. So it's the exact number, right? And so we would say that yes, this estimate is close based on the price for 3.5 miles traveled. Okay, so now she uses a new ride service for her 12th trip, and she travels 4.1 miles and is charged 24.75. Okay, so I'm going to come down here and we're going to say 4.1 and 24.75. All right, so we can see here that is way up there. And how do you think the slope of the equation of the line of the best fit will change when it is added? Okay, that price is higher, so it's going to reflect that, and so the line's going to want to try to move up. All right, so we can see here, if we go back to right here, our slope was 1.57. Now we look at our new slope and it's 2.14. Okay, and so we can see here the slope increases to basically, guys, $2.15. Okay, and so that's a good way to see. And we can see that's an outlier. It's not a very good service. You know, the first one was cheaper. And so which of these, okay, so we are done with the data. And so now, guys, what we're going to do is we're going to go ahead and pull this back up. And which one of these scatter plots shows the data that would best fit a model with a linear function? All right, and what we would say here is C, that is this one here, because the data is in the form of a linear function, just basically meaning, guys, it is straight. Okay. And that is pretty much it. And so the last one we would talk about here is here. And so we would say which of these lines is most likely to be the line of best fit for the data provided. Okay, and so we look here, guys, and the main thing that we're really going to look at, okay, is these lines. And so as we see, the line is increasing from left to right, and so we automatically know, I'm going to move down just a little bit. I wish I could zoom out more, but this is where we're going to be at. And so we see here, perfect. Okay, what we can do is we can cross out this one and we can cross out this one because we want a slope that's increasing left to right. And so what we see here is I've got a slope of 0.34 and a slope of 0.98. And so in looking at that, guys, what we could say is, okay, if it's at 0.98, that's roughly a 1-to-1 ratio on the moves. And so what we know is, hey, take a 20, right? Because we think that maybe that slope, okay, if we're drawing a line, like maybe this is my line, maybe, okay? And so what we would say is, in that line, hey, if I'm at 30 here, the slope is 1-to-1. So to get to here, I'm going to have to get up 50 spots. So if, say, for example, I was here and that slope was 1, the next dot, guys, would have to be clear up here. It's a 50-to-50 ratio. So we know that that is not true. Okay, and so here would be my lineup best fit, and it would not be this one. All right, guys, that is it for today. Hey, I hope you enjoyed the lesson. Please reach out to me or your teacher if you have any questions for the classwork, and we will see you later.